Okay, so another type of problem that we can work with the chain rule is we can use tables. If we know some values, we know value of a function, and we know the value of the derivative at certain x values. So for these two examples, we're told that g of 1 is equal to -1, and then g prime of 1 is 2, and then h of 1 is 4, and then h prime of 1 is 5. And don't forget, if you were asked what's the tangent line of g at 1, you could completely answer it here, right? You have all the information you need. You have the point, you have the slope. Same thing for h. So we're asked to find f prime of x, the derivative of f, and we're told the function f of x equals the function g of x cubed. So we obviously have two functions here, correct? The inner function, which is g of x, and then the outer function, which is the cubing function. So here, I think these are especially nice, how we talked earlier in the last video about working outside in, right? So the outer thing happening is this cubing process, correct? So if you had something cubed and you took its derivative, right? So actually you're taking kind of the derivative here with respect to g of x, which is a little strange. The notation gets a little wonky. But we would say f prime of x equals 3 times g of x squared, right? We just brought the old power out front, dropped the power by 1. Whatever's inside there stayed exactly the same. Now, because of the chain rule, we did the outer link. Now we go in one. So the inner link is the function g. We take its derivative, which would just be g prime of x. So this would be the rule for f prime of x. Like every quiz or test, when I ask you about those, it's always give the rule, right, and then evaluate it. So now, well, actually, it said we did find f prime of x. I guess, how about then find f prime of 1? Since we have all that information over there, we might as well use it. But then we know that, so f prime of 1, we're just going to take this sentence, and wherever there is an x, we're going to replace it with 1. Bet you expected that, didn't you? So then we could go ahead and look up our values over there. So this will give us 3, and then g of 1, we're told is -1, so that would be -1 squared, times g prime of 1 would be 2. And again, the chain rule is all linked with multiplication, right? Everything's multiplied together. So we get 3 times +1 times 2, so we get f prime of 1 equals 6. Does that seem to work for us? For the next one here, actually, if you want to take a crack at that, go ahead and take a look, see what you get. Okay, and for this next one, we have f of x is equal to the square root of 8h of x. So again, we're not going to deal with the square root. We're going to use a 1/2 power. So we're going to say, let's rewrite this as f of x equals h of x raised to the 1/2 power. So the outer link of our chain is going to be the 1/2 power. Okay, so h of x will stay the same. So the first step of our derivative, f prime of x, and notice, this was not a derivative. This was just rewriting the original function. I labeled it as such, and then here we jump to the derivative. The more you can make that a habit to label what you're doing, it's going to save you some grief later on as we get more and more functions together. So here we're going to get 1/2, and then we get h of x to the -1/2, and then times h prime of x, which is just the inner function there. Just the inner function. So that's our rule for f prime of x. And then to find f prime of 1, we'll get 1/2 h of 1 to the -1/2 power times h prime of 1. Okay, so this one, it might need to think about. This is going to become 4, correct? We know from our data that h of 1 is 4. 4 to the -1/2 power, might think about what that means. So let's see. Isn't that like 1 over 4 to the 1/2? Right, and that's 1 over the square root of 4. Right, so it's just going to give us 1/2. So just kind of keep that in mind. So let's see, we're going to get 1/2 times 4 to the negative 1/2. H prime of 1 is 5. So we just showed that 4 to the negative 1/2 power is 1/2. So we get 1/2 times 1/2 times 5. And that gives us 5/4 for that. And then here was our rule. So that's how tables work in terms of, we're using the same piece. But again, that the definition where this was the more of the f of g of x definition, look to there, it kind of looks the same as that. We're just using that. Now, it's important to really get some practice on this worksheet, on the other problems, because what's going to happen is we start adding links to the chain rule. You know, it gets, if you're not okay with 2 steps, 3 steps is that much harder, or 4 steps is that much harder, but they'll get added in there, and we'll look at some of those tomorrow.